Okay, to start, for group A, we have our biggest group on the top in chlorine, and then always having our largest group at the bottom, here being C3H5. So in this first one, we have both hydrogens here to the left. We have our methyl group here and our C2H5 to the right. As you can see in our Newman's projection, we have the same conformation, having chlorine at the top, the C3H5 at the bottom, methyl to the right, and both hydrogens to the right. On our second molecule, we have the same thing happening with chlorine on the top, our C3H5 on the bottom, but in this time, we have hydrogen on the right side on our front molecule, and hydrogen on the left side on our back molecule. As we can see here in the Newman's projection, we have it set up as chlorine at the top, C3H5 at the bottom, hydrogen on the right, hydrogen on the left, methyl group on the back, C3H5 on the right. And here we have our C molecule, and we have, again, chlorine at the top, C3H5 at the bottom, but this time we have both our hydrogens on the right side of our molecule. As we can see on the Newman's projection, we have chlorine at the top, C3H5 at the bottom, both hydrogens to the right, and the methyl group to the left. On our final molecule here, we have, again, our chlorine at the top, C3H5 at the bottom, but this time we have our hydrogens on the left side in the front, and the hydrogen on the back side on the right. As we can see here, again, chlorine at the top, C3H5 at the bottom, and then in our front group we have a hydrogen to the left, and in the back group we have our hydrogens to the right. And all four of these are isomers of each other, as they have different conformations.
Okay, so here we have A and we have C, and we know that C is a stereoisomer of A. And we can easily see this because you can't superimpose them on each other, right? So we can see the difference here. So A has chlorine atom pointing right, whereas the chlorine atom is pointing left on our C molecule. And also in the back, we have our double bond and our C3H5 pointing downwards, but in this case, it's actually pointing up. So then we flipped our C3H5 and our C2H5 around back there, and our chlorine and hydrogen are switched.
So here we have molecules B and C, and these are disaster mirrors of each other because the two stereoisomers are not mirror images of each other. It's important to note that some but not all stereocenters will have the same absolute configuration. In this case, the hydrogen groups are not mirror images of each other, seen here.
Also along with the methyl groups that are here. So here we have the molecule C. So now we're going to draw a Fisher projection of it. So here is our Fisher projection. This makes sense because the chlorine right here is going into the page, and we also have our C3H5, which is also going into page over here. And then we have our methyl group and our C2H5 and our two hydrogen atoms all on our C molecule. They all are shown to be coming out of the page and pointing out towards us. So this is an accurate depiction of our molecule C in a Fisher diagram. So here we have the molecule C. So molecule C was a diastereomer of molecule B and a stereoisomer of A. So to figure out if it's dextrorotary or levorotatory, we actually have to test it with polarimetry. We can't just look at it and know. We have to test it with a polarimeter. Once we test it with polarimetry, if it rotates and goes clockwise, that would mean it's dextrorotatory. But if it rotates counterclockwise, that would mean it's levorotatory. We know that it's optically active because it's a chiral molecule, and to be chiral, it means that it is non-superimposable on its mirror image. So here we have its mirror image right here. We have our double bonds pointed towards each other, and that coming up, our hydrogens here, and then we have the C2H5 on the other side, and our hydrogen and chlorine and our methyl group right here. So these are mirror images, but if we place one on top of the other, they're not going to work. You first see chlorines are not on the same side, so it's a chiral molecule. So we know that this is optically active. So now we can put our molecule C as a sawhorse representation, which would be this. So to make this, we have our chlorine up here, and it has to be anti to the other biggest group. So chlorine is right here, and our other biggest group is the C3H5, which is right here. And then we have our hydrogen, C2H5, and our methyl group. So as we have drawn it on our sawhorse diagram, we have the Cl going across to here, and our other biggest priority group going across to here, so that they are anti.